Welcome to this tutorial on dilutions and pH measurement. In this tutorial, we will learn to measure change in pH for solutions of acid and base on dilution, variation in pH by common ion effect for weak acids and bases. To follow this tutorial, you should be familiar with Chem-Collective VLabs interface. If not, for relevant tutorials, please visit our website. Here I am using Mac OS version 10.10.5, Chem-Collective VLabs version 2.1.0, Java version 8. For this demonstration, let us dilute 0.1 molar hydrochloric acid to 0.01 molar hydrochloric acid, 0.1 molar sodium hydroxide to 0.01 molar sodium hydroxide. For this experiment, 2 ml of 0.1 molar hydrochloric acid or sodium hydroxide is diluted to 20 ml with distilled water. I have opened a Virtual Chemistry Labs application window. Stockroom Explorer opens with solutions of various acids and bases. Double-click on Strong Acids cabinet. A list of acidic solutions with various strengths opens. Double-click to choose 0.1 molar hydrochloric acid. Click on the flask. Observe the pH on the pH meter. Note that pH meter reads 1. Click on the radio button near Strong Acids cabinet to close the list. Next, from Stockroom Explorer, double-click on Strong Bases cabinet. A list of basic solutions with various strengths opens. Double-click to choose 0.1 molar sodium hydroxide. Click on the flask. Observe the pH on the pH meter. Note that pH meter reads 13. Click on the radio button near Strong Bases cabinet to close the list. Double-click on the distilled water icon from the Stockroom Explorer. Let us now add the required apparatus to the workbench. Click on glassware icon. Select graduated cylinders. From the submenu, select 10 ml graduated cylinder to add to the workbench. For this experiment, we need 2 graduated cylinders. Right-click on the graduated cylinder. From the context menu, select Copy. Place the cursor at a different place. Right-click and choose Paste option from the menu. Click on glassware icon. Select Erlenmeyer's. From the submenu, select 250 ml Erlenmeyer flask. We require 2 flasks. Right-click to copy and paste. Label the graduated cylinders as A and B. Right-click on the graduated cylinder. From the context menu, select Rename option. A text box opens. Type A in the text box and click on OK button. Similarly, label the other graduated cylinder as B. Similarly, label Erlenmeyer flasks as A and B. Place each set of apparatus at a different position on the workbench. Use Set A for acids and Set B for bases. To perform this experiment, we will dilute 2 ml of 0.1 molar hydrochloric acid with 18 ml of distilled water. Drag 0.1 molar hydrochloric acid flask over to the graduated cylinder A. In the transfer amount input bar, type 2. Click on Pour. Move the flask aside. Move the distilled water tank over flask A. In the transfer amount input bar, type 18. Click on Pour. Move the distilled water aside. Place the graduated cylinder A over flask A. Change the transfer mode to realistic transfer. Click on Pour button gradually. Move the graduated cylinder A aside. Click on Flask A. Observe the pH on the pH meter. pH meter reads 2. Similarly, let us dilute 0.1 molar sodium hydroxide and measure pH. Measure 2 ml of 0.1 molar sodium hydroxide in graduated cylinder B. Drag 0.1 molar sodium hydroxide flask over to graduated cylinder B. Using Tools menu, change the transfer mode to Precise Transfer. In the transfer amount input bar, type 2. Click on Pour. Move the flask aside. Move the distilled water tank over flask B. In the transfer amount input bar, type 18. Click on Pour. Move the distilled water aside. Transfer 2 ml of sodium hydroxide from graduated cylinder B to flask B. Place the graduated cylinder B over flask B. Change the transfer mode to realistic transfer. Click on Pour button gradually. Move the graduated cylinder B aside. Click on Flask B. Observe the pH on the pH meter. pH meter reads 12. Here is a table which shows results of our experiment. pH of 0.1 molar hydrochloric acid is 1. When diluted, acidity decreases. After dilution, pH was found to be 2. Similarly, pH of 0.1 molar sodium hydroxide is 13. When diluted, alkalinity decreases. Hence, after dilution, pH was found to be 12. Since pH is a logarithmic scale, for every 10 times dilution, pH changes by 1 unit. Back to the workbench. For the next experiment, load a new workbench using File menu. Click on Workbench 2. Let us study the variation in pH by common ion effect. We will demonstrate this using weak acids and weak bases. For this demonstration, we will use two examples: ethanoic acid and its conjugate base sodium ethanoate, ammonia and its conjugate acid ammonium chloride. Back to workbench. Place the required chemicals from the Stockroom Explorer on the workbench. From Stockroom Explorer, double-click on Weak Acids cabinet. A list of weak acid solutions with various strengths opens. Double-click to choose 1 molar ethanoic acid. Close the list. Again, from the Stockroom Explorer, double-click on Weak Bases cabinet. A list of weak bases with various strengths opens. Double-click to choose 1 molar ammonia solution. Close the list. Double-click on Conjugate Acids cabinet. Double-click on 1 molar ammonium chloride solution. Close the list. Double-click on Conjugate Bases cabinet. Double-click on 1 molar sodium ethanoate solution from the list. Close the list. Next, click on New Glassware icon. Select 250 ml beaker. We need 4 beakers for this experiment. Right-click on the beaker. Using Copy and Paste option, make 3 copies of the beaker. Label the beakers as A, B, C and D. Place the beakers A and B to one side of the workbench. Place the beakers C and D on the other side of the workbench. Place ethanoic acid and its conjugate base sodium ethanoate on one side. Place ammonia and its conjugate acid ammonium chloride on the other side. Transfer 25 ml of ethanoic acid in beakers A and B using precise transfer mode. Type 25 in the transfer amount input bar. Click on Pour. Similarly, transfer 25 ml of ethanoic acid to beaker B. Move the flask aside. Transfer 25 ml of ammonia solution into beakers C and D. Move the flask aside. To demonstrate the effect of common ion, transfer 25 ml of sodium ethanoate into beaker B. Place 1 molar sodium ethanoate flask over beaker B. Type 25 in the transfer amount input bar. Click on Pour. Keep the flask aside. To check the pH of 1 molar ethanoic acid present in beaker A, click on beaker A. pH meter shows pH value of 2.38. Click on beaker B. pH meter shows value of 4.76. Now transfer 25 ml of ammonium chloride into beaker D. Place 1 molar ammonium chloride flask over beaker D. Type 25 in the transfer amount input bar. Click on Pour. Keep the flask aside. To check the pH of 1 molar ammonia present in beaker C, click on beaker C. pH meter shows pH value of 11.62. Click on beaker D. pH meter shows pH value of 9.25. Now let us tabulate the results. Due to the presence of common ion, that is ethanoate ion, ionization of ethanoic acid decreases. Hence, pH value increases. Similarly, due to the presence of ammonium ion, ionization of ammonia decreases. Hence, pH value decreases. Let us summarize. In this tutorial, we have learned to measure change in pH for solutions of 0.1 molar hydrochloric acid and 0.1 molar sodium hydroxide on dilution. Variation in pH by common ion effect for ethanoic acid and ammonia solutions. As an assignment, measure change in pH for 1 molar and 0.01 molar sulfuric acid, 1 molar and 0.01 molar sodium hydroxide. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Please post your timed queries in this forum. Spoken Tutorial project is funded by NMEICT MHRD Government of India. More information on this mission is available at this link. This tutorial is contributed by Snehlata Kaliappan and Madhuri Ganpati from IIT Bombay. Thank you for joining.